So I wanted to make this video to show, now that you've made Tic Tac Toe yourself, to go over a few things about how I would do it, and also some of these will give you hopefully some ideas of how to work on your current projects, which are a little more elaborate than Tic Tac Toe. So I have started here with basically what you would get if you started the Simple Web project. So the very first thing I'm going to do, not strictly required, but might as well go ahead and change the HTML to say what we're doing, tic-tac-toe, and then instead of, and I believe I have the screen right here's the page as it is, as the server is running. I've already run the run script, so I can change this. Instead of the H1 saying hello world, I'm going to make a board with the ID board. Close that. All right, so now I've got a board, and that'll be good enough for now. Maybe I'll pop over to this style sheet. I don't need this H1 and P styles anymore, and I'm actually going to do the styling on this body a little bit differently. So I'm going to use our, this is just one way to do it, but I'm going to make a flex display. I'm going to make my flex direction column, so it makes a column of things in it. There's actually only going to be one or two things, and I'm going to justify the content to be centered, so that'll put it centered vertically, and then I'm going to align the items also centered so they'll be centered horizontally, and I think that should do the trick. And then I need to style my board, which is the div with that ID, so I use this selector here, pound board, and I want to make its display as, if you did the Tic Tac Toe project, you got the Tic Tac Toe kit that set this up for you, so I have to do it myself here. A grid display with the template columns repeating one FR I think stands for fraction, so one fractional part of the three repeated columns, and then the same thing for the rows template, 1 FR. So now I've got a grid of three columns, 3 rows, and then I'm going to set the size of this, and I'm going to use a funny unit. Vmin is the 50 vmin. V stands for visual, and so that's sort of actually how much space there is on the screen, and min, I could say VW, which would mean 50 is kind of a percentage, so 50% of the visual width of the screen. And for height, I could do 50 VH, except I want my board to be a square, so Vmin is whichever is smaller, width or height. So this, let me make a square that's sort of going to be 50% of the size. And as a debugging thing, maybe not even debugging in the sense that I don't think I have a bug yet. Maybe I do. I'm going to make a 1 pixel solid black border around this board that I've set up. And now I can go over here and load it and wonder why it didn't change. I need to save this file. I'm working on a local editor that doesn't automatically save things. So there's that. Oh, and I said it was going to be centered vertically, and the reason it's not, I can actually now debug. If I hover over the body, I see the body is not filling up the whole screen. It's just big enough to hold what's in it, which is this board, which I set a specific size of. So if I actually want this to be centered vertically, I can do that in my style by making I'm going to make my body 100% of the vertical width and 100% of the vertical height. Save that and reload, and now the board is centered, which is maybe, I don't know, maybe I want the board a little higher later on, but this is good enough for now. So I can go back here to my editor. So the style looks reasonable. And that's really all it's going to look like until I put some stuff inside this board. So let's go ahead and do that. So you've all done this, something like it. I'm going to start by, I'm going to just call this display, and I'm going to get the board from the HTML. So I'm selecting the element that has the ID board. And now I can, oops, writing JavaScript, not Java. Write my loop, 3 rows, and inside that, a loop of 3 columns. So this inner, where the cursor is now, is going to run 9 times. So 9 times I want to create a cell, and I think you all did this pretty much like this. So I'm going to create an element, I'll make it a div, and then I'm going to append it to the display. And why is this red squiggly here? I think that's fine. We'll find out. Okay, let's go over to the browser. Notice I have the console open. So if I, oh indeed. Oh, sorry, I got faked out. That should be 4. I got a little carried away with my lets. Okay, save that. So, good sign, like, and notice what I did there. Like I saw the red squiggle, it didn't seem wrong, so I just went over to the browser and I ran it, and I let the browser tell me exactly what line it was on, line 4. This unexpected strict mode reserved word is maybe a little cryptic. I happen to have seen that before, so I knew what the problem was. But at least I would know to look back at line 4 and check my thing and see that, oh wait, I meant to write a for loop there. So now, no errors, looks the same, but if I look in the inspector, I see that all these divs are here, and we can see when we highlight them that they're in the right place thanks to the CSS. So now what I want to do, maybe I'll pop over back to the CSS, and let's give those divs a little style. So I think many of you learned about this selector, which basically says select the divs that are directly inside of, that's what this little greater than sign here means, directly inside of the board element. And so I'm going to set their background to be white, and then I'm going to set the background of the board to be black. And you might think, what's that going to do? But then I'm also going to use the gap attribute, which is part of the grid layout, to say, let's give a 4-pixel gap between the cells of our grid. Save that, come over here, and now we see our Tic Tac Toe board. And we still have this box around because of the original border, which I don't like, so I'm going to take that out. So the border attribute is what's giving us that border. Take that out. All right, now we have the Tic Tac Toe board. So now we're about to where we would have been if we had started with the Tic Tac Toe starter code. Okay, so we've got our board in place, get the cells getting added to the board, and now we need to start the logic of actually playing tic-tac-toe. So I'm going to go ahead and do this a little bit differently than you probably did tic-tac-toe, though not that differently. Okay, so I'm going to make a board array, which I'm going to use, I'll put a comment on here, to represent the state, the board. So the marks on the board. And then the cells in the display, I'm going to put also in an array. So this is something that wasn't really necessary for tic-tac-toe, but is something a lot of you are doing now in your more complex projects like Connect 4 or Super Tic-Tac-Toe or whatever. So we've got 2 arrays. They start out empty, which is fine, but we're going to build them up in these loops. So for each row, so before we start the loop for the column, just at the beginning of each row, when R0, R1, and R2, we're going to push onto our board a new empty array, and we're going to push onto our cells a new empty array. So those 2 empty arrays are going to be different each time this executes, we get a brand new empty array. And we're basically pushing an array which is going to represent the row in the board and also a row of cells. So then, after we've appended our cell to the display, we're going to turn around and get the row that we just added by board index R. So that's going to get this row, and we're going to push onto it an empty string, and we're going to do the same thing with the current row of the cells array, and we're going to push the cell itself onto that. And just for grins, let's see what's going on here. I'm going to log the board, and I'm going to log the cells. Save that, run it, go over to the console, and we can see at the top level they look the same. They're just a 3 element array that contains arrays. The first one, which was the board, contains a bunch of arrays containing empty strings, and the board of cells contains arrays containing these div elements, which in fact, I think if I expand this and hover over, we can see those are the actual divs in the, if you look on the screen where it's highlighted, those are the divs, and if we expand this row, there's the divs down here. Okay, so let's talk about how we're going to use that. So we've got this board where we're going to keep track of the marks, and we've got the cells, and we'll see why in a second we need those. So now, as you may recall, we need to do something when each cell is clicked. So I'll go ahead and write cell onClick equals a function that takes the event object and is going to do something. And I'm going to go ahead and imagine, rather than write it all here, which is how we mostly did it before, and that's fine, but sometimes it's nice to keep the code a little simpler by moving things out into a function. That's actually going to be a theme of how I'm doing things here. So I'm going to pretend for the moment that I have a function called maybe_move, because as you recall, like every time a cell is clicked doesn't necessarily mean there's going to be a move, but we're going to maybe move at the row and column that this cell is part of, right? And so this R variable and the C variable we can refer to here. And so this function, each cell gets its own function that all call maybe_move with their own value of R and C. So now let's make our dreams come true and actually write maybe_move. And so this is going to be the function that's going to maybe_move. And if, again, we wanted to see what was going on, I could just console log something or plus typing problems plus C. So right now, this is just going to check that, like, is this function getting called when we click, and does that function call maybe_move? If so, we should see stuff coming out in the console. So there's our 2 original, and now I can see it's printing out the right coordinates for each square over here in the console. So that's great, but that's obviously not what we really want to do. But now that I know it's working, I can delete that and say, okay, so how do we decide if we're going to move? As you probably recall, we only want to move if that cell is empty, which we're keeping track of in our board array. Now you could use cells and get each cell's inner text and check if it's empty. And this game is simple enough that would kind of work. But as things get more complex, you know, or maybe we're going to make our HTML more complex, and the cells themselves might have some internal elements or something. So the advantage of having this board array is that it doesn't need to do anything but keep track of the marks. So we can just be sure that it's always going to be either an empty string if it's empty, or a mark if we put a mark in it. And then we just have to keep the boards and the cells in sync, which is what this function is going to do. So if the board at the given row and column is empty, then we can make a move. So I've got my if, and basically if that's not true, we don't want to do anything in this function. We just want to ignore the click. So now inside the if, we can decide what we're going to do if that board position is empty. So as you probably recall, we need to alternate between X's and O's, but maybe we don't start with that. Maybe we just say, okay, the main thing we need to do is we need to update the board. So let's just say it's always going to be X for now. And like I just said, we also have to keep the cell on the display in sync. And so this is why I made that cells array. We can use the same coordinates for each position. There's a thing in the board. There's also the cell that displays that position in the board in our cells array. And so we can set the inner text of that cell also to be X. And so now if we reload and click, we see this little X up here. So that works. We can put an X everywhere. And so now there's a couple problems. One, this X is tiny and in the wrong place. Two, it's always an X. I guess that's the two problems I see right away. So I'm going to go ahead and first fix the aesthetics of this situation. So I'm going to go to my style, and I've already got this rule that describes how the divs inside the board are laid out, and I'm actually going to use the same trick I did in the body itself. Use a flex display, organized in columns, justified, center, and that should put the X in the center of the div. And there it does. And that's a little bit small. So let's come over here and we can change the font size. And I'm going to actually use the same vmin style unit. I could just set this to some particular font size, but since we sized the board relative to the screen size, let's size the font the same way. So we want kind of a third of the board size, which would be 50 divided by 3. I'm just going to go with 10. That's because I don't want it to be too big anyway. So I can use this same unit, and I can then load the page and see how it looks. That seems fine. And I'm going to make sans serif font family. These are called serifs. These little things sticking out on the end. If I change it, now I get a nice clean sans serif. Okay, so now I'm back to the problem that it's all X's. So back to our code to fix that. Probably many of you remember the trick for that is we keep track of what move we are on. And that's a variable that we declare with let because it's going to change. The board and the cells don't change. The contents of them change when we push stuff onto them, but the variables themselves never change after we create these arrays. But the move is going to change, and it changes exactly when we make a move. So if we get into here and the cell isn't empty, we're going to increase our move by 1. And then we can use that move variable to determine what mark we want to make. And I'm going to make a variable mark. And if the move remainder 2 equals 0, meaning if the move is even, the mark is going to be X. Otherwise, the mark is going to be O. And now I replace my specific value of X with the value of that variable. So this is the point of making variables, that we can get a value once and then use it in multiple places where we need to refer to it, or where we need the same value. We want to put the same mark in the board and in the text of the cell. So save that, and because of the way we did the move from the beginning, we don't have the problem of moving over top of an existing move. So now we've got the ability to fill in the cells, and we need to move on to detecting wins and losses. So let me hit format, just make sure everything's tidy. Great. So maybe makes a move, and we're gonna come back here and let's just, again, we can sort of imagine what we wanted. Imagine we had a function is winner, and I'm going to go ahead and write this function to take the board as an argument. This is a little bit unnecessary in this program because board is declared up at the top of the file, which means we can refer to it anywhere in this file. So we could just write isWinner and it could refer to board. But it's sometimes nice to show exactly what a function depends on by passing in the information it needs. So to determine whether there's a winner, we're going to pass in the board because that's how it's gonna, what it's going to operate on. And we're going to assume it's going to return true or false. If there's currently a winner on the board after we've just made this move, this can return true. And so we'll go ahead and log. Let's see, what do we want to do? Console log. Let's just log winner. Right now, we could do it this way. So given the current row and column, the mark after we've made the move is going to be in the board. So we can say that mark wins. Right, whatever, if X just played, that'll be X. If it's O, it'll be O. And we'll console log that wins. Now, obviously, this isn't going to work if isWinner isn't defined. So we got to define it. Takes the board as an argument. And you might wonder, well, this is the same name as that. Why do we even need it? Again, this is just because it's a good idea to write functions that take the information they need. This would be really handy for some of you who are working on Super Tic Tac Toe. You're going to need a function like this, but you're going to have 10 different boards you care about. So you won't be able to just use what we call a global variable. You're going to have to pass in which particular board do you care about. So I'm going to go ahead and write it this way. Keep things a little tidy. Okay, so, and let's just return true for a second. This is another pattern of just like, rather than writing a whole bunch of code and then having to debug it, first I just want to make sure that like the basics are working. So I should see it saying that someone won basically after every move now. X wins, O wins, X wins, O wins. We see coming out on the console. So the basic machinery is working. But obviously that's not a very good isWinner function because it's always returning true. And I'm going to delete these console logs now. Okay, so now we need to do something smarter about this. Now, there's a bunch of ways to write isWinner, but I'm going to try and demonstrate some ways you can break things down into smaller functions. For instance, what if I had a function 3 in a row that took, let's call it a line. So this is going to be an array of 3 marks like we get from a single row or a single column or even a single diagonal from the board. And it's going to tell us whether that line contains 3 in a row. And so here we can write the logic that I'm sure many of you arrived at some point. We check if the 0th element of the array is not empty. So it's not equal to the empty string, and the 0th element of the array is equal to the element 1, and the 0th element is equal to element 2. So basically, it's not empty, and all 3 are the same. They're all the same as the first one. So that function returns true when that array, like assuming that array was something like x, x, x would return true, but if it was xx that or xxo, it would return false. So with that function in hand, we can come back to isWinner and say, well, how do we check if there's a winner? So rows are easy because the board is already arranged where the elements of the board, as we saw in the console, are themselves rows of 3 things. So we could check for a winner in the first row by returning 3 in a row, board 0. And so now I think if I save that and I come back here and I let X win in the first row, notice how it's not printing isWinner yet, and now it prints it because we just checked the first row. But if I win in the middle row, it's not going to notice well, now it notices that O wins, but it didn't notice when X won because it's not checking the middle row. But that's easy enough to fix. So we could write 3 in a row board 0 or 3 in a row board 1, but 3 is enough. Let's write a loop. So we're going to go from from 0 less than 3, I plus plus, and I'm going to move this line of code, triple click to select it, Command X to cut it, paste it, and instead of board 0, I want to check my index variable, board I. So this will check, but I don't always want to return, because if this returns false the first time when I is 0, I don't want to give up. I want to keep going and try I is 1 and I is 2. So I need to introduce an if statement here. If we find a winner, then return true, because as soon as we find a winner, that means there's a winner on the board. And otherwise, no winner found. Down here, we return false. So this is a basic finding loop, I guess it's an any loop, right? If any of the rows are 3 in a row, then we found a winner. Otherwise, we didn't. So this game should now be able to detect a winner in the middle, X wins, and even in the bottom. But it will not detect a winner in the columns because we haven't done anything to do that. And now we need to say, well, how do we get a column that we can pass to 3 in a row? Or do we need to write some completely different code? So since we have 3 in a row, let's write a function that will extract a column from the board given its number. So column 0 should get the left column 1 will get the middle, and so on. So this is another place to use a for loop. This is a collecting for loop. I'm going to make our line, I'm going to call it line to suggest that like this, we're building a thing here that we'll be able to pass in there. Doesn't have to be. We could call this column too, though that's a little confusing because it's the same name as the function. So let's call it line. And then we're going to loop over the 3 rows. And again, we can call this anything, I or R, whatever you want, but R because it stands for rows. And then we're going to push onto our line the mark that we find in that row and in the column where C is the argument that was passed in. And then after we've looped 3 times and pushed stuff into this line, we're just going to return it. So now we can actually, right in this loop, do the same check, 3 in a row, column, board I. So I is our number that's going from 0, 1, and 2. If we find 3 in a row in a column, we should return true. And so now it detects the win X1 in the first column. So all that's left is a diagonal. Obviously there's only 2 diagonals, not 3, so we don't probably want to use this loop. Also, diagonals aren't numbered in quite the same way. So we can just go ahead and say if, and again, I'm going to imagine a function I wish I had. I'm going to 3 in a row, and I'm going to call it diagonal 1, for lack of a better term, board. And the diagonal function is going to know how to extract that particular diagonal. If the line that diagonal 1, a function we're about to write, returns is a 3 in a row, that's a winner. And then I'm going to copy that, paste it twice, change this to diagonal 2, and return true. And if those, as soon as we write those functions, we'll be all set. So const diagonal 1 takes the board as an argument. And this one still can use a loop because we're looping 3 times. I'm using I this time because it's neither row nor column, as we'll see. And we want to follow the same pattern of making an array, and then we're going to return the array at the end, and now we just have to fill it in. And so the diagonal, the first diagonal that goes from left to right is 0, 0, 1, 1, and 2, 2. So that means we can push the value from the board where the row and the column are the same. So 0, 0, 1, 1, 2, 2 gets pushed on our line. And then I'll just go ahead and copy this whole thing. Diagonal 2 is basically the same, except if you think of it as going from the top right square, it's in row 0 and goes to row 1 and then to row 2. So the first dimension is the same, but the column starts at 2 and goes to 0. And so one way to do that is a tiny bit of math. 2 minus I. When I is 0, it will be 2. When I is 1, it will be 1. And when I is 2, it will be 0. So that will give us the diagonal running from top right to bottom left. So save that. Reload. X, O, X, O, X. X wins, so it's detecting that diagonal. X, O, X, O, X. X wins, it detects this diagonal. So it looks like our all our checks, rows, columns, diagonals are all working. And this might seem a little complicated compared to what you wrote, in the sense that I have a bunch of different functions. But I'd suggest that it's actually, and once you get used to it, functions are great because they let you focus on one thing at a time. So in the editor here, I can collapse these and say, all right, I've got these functions. I just have to remember what they do. So column extracts a column, diagonal 1 extracts one diagonal, diagonal 2 extracts another diagonal. And I can look at the code and see what it does, or I can now treat them as kind of black boxes that they do what they're intended to do, and then I can see that I'm using them up here in a particular way. I might even be tempted, just to keep things tidy, to write a row function, even though it's kind of totally unnecessary, but just to sort of show the parallelism. And the row function is going to just return board R. And then here, instead of directly accessing the board, I get it with my row function. That's maybe a little, your taste on whether it's useful to write that function. The reason to do something like that is that later, maybe if I change how I represent things in this board array, then I will change all 4 of these functions in some similar way. But maybe that's a little too much looking to the future. But either way is fine. So now I've got an isWinner function that works, and I'm console logging, which is cool. I know it works, but I probably want to actually put something on the screen. So now basically our last step for this simple game is we go back to our HTML and say, okay, I want to have a place to stick the result. So I'm going to go make another element, call it result, and it's just another empty div, or I could make it a paragraph, doesn't really matter. And now I can have that. I am ready to come here where I log the win, and instead I just have to say document query selector result to get at the element that I just set. And I'm going to take exactly the same thing that I logged, copy that, paste it here, and I'm going to set the text of the result to be the same thing as I logged. And now if X wins, cannot set properties of null, line 24. What did I do? You know what, I bet I didn't. I forgot to save this HTML. Try that again. Great. So that actually illustrates another point, which is whenever you make a change and something breaks, especially if you've been testing frequently, it's pretty easy to find what I did wrong, because it told me exactly the line. and it told me the problem. And obviously you have to have a little bit of experience to know that when it's complaining about null or whatever, it's maybe because it was trying to get the inner text. Well, that meant this thing was not returning a value. But I could think, well, what else did I just do? Oh, the other thing I did was I edited the HTML. So then I come over here, maybe I misspelled the identifier, maybe I, the ID. Or what in fact happened is I forgot to save this file, which you won't have that problem because in the code spaces, it saves automatically. But it can only have been a couple of things. I had just added this line. I had just added this line. One of those two things had some little detail that was missing. And, but having fixed that, this works. That style is a little bit small. So let's maybe one last thing. We'll pop back over here and add a little style to the result. And we'll make it the same, relatively big. Let's make it bigger. 20% of the size. Save that. Come over here. XOXOX. Well, okay, that was too big. Maybe 5. Or I could just go with 64px. Doesn't really matter. Oops. Okay, that seems fine. Obviously, this could be made more attractive in many ways, but that's not really the point of this exercise. Though I do realize we missed one last piece of the logic of the game, which is we detect a winner, but we don't do anything if the game is tied. So I'm going to take this console log out, just keep things tidy. And the logic of ties is actually pretty easy. After each move, we check if there's a winner. And if there's not a winner, could be the game is still going. Or if we're on move 9, then it's a tie. So we're going to want to, I'm going to copy that line, paste it here. And instead of saying that someone has won, I'm going to just say tie. And that is basically, that should do the trick. So now I'm going to play a game and try and tie. And we get the report of the tie. So that is the whole game. I guess the very last thing I would do, just to show, it's fine to have this code here. This is kind of at the top level of the code, but even better, and a good habit to get into, is to write almost all of your code in functions. We might declare a few variables up here, but I'm going to go ahead and make a function called setup that takes no arguments. And I'm going to put the closing brace down here after all of this loop that does the setup. You can reformat to get everything indented. And if I just run this, give you a second to think about what's going to happen. So I've taken all this code and I've put it into a function. So it should work the same or different. What do you think? Okay, I get this black screen. The board has the grid, but there's no elements inside the board. What happened? Well, if you knew that was going to happen, you know what I need to do. Or now seeing it, maybe you know. I've made a function. This is just defining a thing that I can call whenever I want, but it doesn't actually run this code until I call it. So now I come down to the bottom of the file and I call the function setup to kick things off. So in this case, this is not like a big win, but now we're back to working the way it did before. Okay, so now I've got everything in a bunch of functions. There's slight ways we could reorganize this. One thing I can do now is, and this is one of the reasons it's good to put things in functions, is in fact the only place I use display is here. And so I don't have to put that at the top level. I can put it inside my function. And you might ask, well, what's the difference? Like, why is that any better? And I'd argue that it's better because if you recall that this variable now only exists inside these braces. I think I talked about the scope of a variable. So this name only has a meaning inside these braces, which means now we don't have to worry at all about, is display used anywhere else? I've collapsed these functions, but with this function written this way, I know that none of these functions can depend on display. So if I wanted to change something about it or change its name or whatever, I know that it only kind of matters inside this code setup that I just collapsed. So in general, having variables in as constrained a scope as we can, which is kind of why we define cell here. This name refers to this cell that we just created in this loop, and then the next time we come around the loop, there'll basically be a new variable, happens to be called cell, but each time through, this name doesn't leak outside of this loop. So I guess that's the last little thing. So now our program consists of these three variables that really are global: what move we're on, the state of the board, and the cells that we use to display the board, and a bunch of functions. So this is how good programs are structured. We have like lots of little functions that do well-defined things, and not too much free-floating variables. So hopefully that's useful. Hopefully this maybe gives you some ideas about how you can structure things a little differently in your current project. And so that's that. All right, thanks for watching, and maybe I'll make another one of these about something else soon. All right, take it easy.